Namaste, namaste to all my beloved friends. A hearty welcome to the series of short videos on the fundamental concepts of mathematics. In particular, totally dedicated to high school level mathematics syllabus. Myself, T.K. Prasanamurthy, better known as TKP from Bangalore South. And the name of my YouTube channel is this High School Maths TKP with a hyphen in between. In this channel, you will be able to see more than 50 videos on different concepts of mathematics. All these years, I was sharing my PowerPoint presentation in the video format without audio. But now onwards, you will be listening to the audio also. This is a small change I have brought in. Okay, and today's topic is this logarithms, an inverse process of exponent, one of the greatest discoveries that the world has seen. It was a boom to physicists and astronomers for the arithmetic computations during 17th century. Logarithms. It's a Greek word and it is composed of two different words. Its etymological meaning is this: logos plus arthmos. Logos means, normally we know that it stands for reasoning, but it also stands for ratio. And then arthmos means numbers. So this is the etymological meaning of logarithms. In this video, we shall discuss the fundamental concept on which the two log tables are developed. And the two log tables are, number one being, the first one being natural logarithms, and the second one being common logarithms. Natural logarithm concept was conceived and developed by John Napier, okay, who lived between 1550 to 1617. He is from Edinburgh, Scotland, and he published this paper during 1614. And he calculated this table by taking E as the base. And you know E is nothing but 2.71828, etc., etc. And in fact, this is a non-terminating and a non-recurring decimal and one of the important irrational number, just like pi. And now E, that lowercase e, stands for Euler number. And this is the image of John Napier. Now, how about the common logarithms? This common logarithm was developed by Henry Briggs, who lived between 1556 to 1630, and he is from Halifax, United Kingdom, and he published this paper during 1624, but the base he took was 10. Okay, and in fact, he calculated naturally this common logarithm up to 14 decimal places to the integers from 1 to 1000. And this is Henry Briggs' image. I salute I really salute both of them for their wonderful contribution. And here you will see the map of Edinburgh and Halifax, the two places where the heroes of today's topic were born. Okay, fine. Now it is worth to see the tables also, both the tables, natural logarithms and the common logarithms. And Napier, you may not believe, he took about 20 years to develop this table, whereas Briggs took about 7 long years to construct, to develop this beautiful table on common logarithms. Okay, let us take an example and try to understand the concept on which Napier thought about this logarithms. So multiply 32 by 128. First we multiply from the units place, that is 2, 128, 2s are 256. Then the 10th place being 3 we multiply, and that we get 384. We add them up in order to get 4096. So this is our usual multiplication. Do you have any other idea, friends, how we can multiply this? Okay. Alternatively, this can also be done by constructing powers of two table. Powers of two table, and here we have powers of two table. The powers being from 0 to 16. Okay, the values we are able to see now: 2 power 0, 2 power 1, 2 square, 2 cube, and 2 power 16 is 65,536. Now, can you make use of this table of powers of 2? And is it possible to multiply 32 and 128? You have any idea? Okay. 32 can be written as 2 power 5. Okay. Into, and 128 is definitely 2 power 7. So 2 power 5 into 2 power 7, it is in the index form now. How to simplify this? Any idea? Yes, the first law of indices will help us to simplify this further. A power m into a power n is actually a power m plus n. So using this, we can simplify this and say that the answer is 2 power 5 plus 7, which is clearly 2 power 12. Oh, we have got 2 power 12 already in our table. We have calculated 2 power 12. Look at the table, and it happens to be 4096. So 2 power 12 is 4096. So this is how we can calculate the product of 32 and 128. This is all another method, but we should have a table like this. Okay. Finally, what is the takeaway from this PowerPoint presentation? From this slide, it is this: multiplication problem. Napier, he thought that he can be converted into addition problem. This is what he could understand, and with this fundamental concept, he has developed the entire natural log table. So we all agree that addition is definitely much easier than multiplication. This is how Napier developed the log table by converting multiplication problem into an addition problem. But for this to happen, we must be ready with the tables for, like the powers of 2, powers of 3, powers of 4, etc., etc. Okay, once again concentrate on this powers of 2 table. In the above table, we observe that there is a wide gap between the powers of 2, for example, say if you take 32 and 128, what about 31, 33, 34, 35 up to 127? How to find, say, for example, the product of the numbers which are in between 32 and 128? These are which are not the powers of 2. Can you think for a while, friends? This is a very important question. Using this table, definitely it is not possible. But how Napier could resolve this problem? Okay, this I would like to address in my next video. Thank you. Thank you very much for watching. Namaste. Namaste, friends.